6.6, you need your calculator again for this section. We are going to be solving exponential and logarithmic equations. So we're going to start with exponential equations. So logs and exponents are inverses of each other. So if we have an exponential equation, we can take the log of it to get our x from out of the exponent. So logs will be helpful when solving exponential equations. Another thing that's helpful to know, if we have the same base, so let's say I had 3 to the power of x, that's equal to 3 to the power of 5. We could cancel out the 3's and we'd just be left with x is equal to 5. So let's do some examples. So we want to see, can we make these have the same base? So without changing the value, we just want to change the way that the base looks. I can make 100 10 to what power? 10 squared. So it'd be 10 to the power of 2x, because we still have that x there. So I didn't change the value. 100 is 10 squared. These are the same thing. So I just changed the way that it looks. Now this is equal to, now I want to make 1 over 10 be 10 to some exponent. So 1 over 10 would be 10 to what power? -1, awesome. A negative exponent turns it into a fraction. So I'm not changing the value, I'm just changing the way that it looks. So I'm changing 1 over 10 to be 10 to the power of -1 times x minus 3. So when solving our equations, if the bases are the same, we can cross them out and say 2x is equal to -1 times x minus 3. We just set the exponent parts equal to each other. Get rid of the bases and set the exponents equal. So it only works when your bases are the same. And then from here, we're just going to solve for x like we know how to do. What should I do first? Distribute the -1. Awesome. So 2x is equal to -x plus 3, because -1 times -3 would be positive 3. What could I do next? I can add the x, move it to the other side. So 3x is equal to 3. Then what would I do? Divide by 3. So x is equal to 1. Awesome. That would be our answer. So in the beginning, we just wanted them to have the same base. So we needed the same base to cancel them out. Let's look at the next one. So 2 to the power of x is equal to 7. Here, could I get them to have the same base? Can I make 7 turn into 2 to some power? Does 2 to any power give me 7? No. So if we can't have them have the same base, then we have to use logs to cancel. So if we can't get the same base, then use logs. So whatever number has the exponent, that 2 has the exponent with x in the exponent. 2 is going to be my base. So I'm going to take the log base 2 of both sides of the equation. So log base 2 of 2x and log base 2 of 7. Now I can do this because I'm doing it to both sides. So I'm still keeping my equation balanced. I'm just taking the log base 2 and log base 2 of both sides. Okay, now we did this in 6.3. Log base 2 of 2x would simplify to what? Just x. Log base 2 of 2 cancels. We're just left with the x. So x is equal to log base 2 of 7. Because it's the same base, so they cancel. So that's why we took log base 2 of both sides, because we knew it was going to cancel out with this 2. Now log base 2 of 7, what can I do to find out what value that is? We just did it in the last section. The last section that we just did in the homework, the last question that we did. We use our change of base formula. So which one would go on top? Log of 7 divided by log of 2. And then we put this into the calculator. .807. I don't think it tells us how many to round to, but we can just round to 3 decimal places. 2.807 would be our answer. All right, let's try it again in the next one. Could I make 5 have a base of 2, be 2 to some power? No. So what do I need to do to get that x out of the exponent then? Log base 2, awesome. So I'm going to take the log base 2 of both sides. So I have log base 2 of 2 to the power of x is equal to log base 2 of 5. On the left side, what's log base 2 of 2 to the power of x simplified to? Just x, awesome. So log base 2 of 2 cancels, we're just left with the x that's in the exponent. On the right side, how could I put this in my calculator? The change of base formula, so log of 5 over log of 2. So we get 2.322. For number 2, so I have a base of 7. Could I make 15 be 7 to some power? No. So what do I have to do if I can't get them to have the same base? Log with what base?
9.
No, log base 7, because 7 is the number that has the exponent. So log base 7 on both sides. So log base 7 of 7 to the power of 9x is equal to log base 7 of 15. What do you think I can do next? Perfect. Log base 7 of 7 cancels, so I'm just left with 9x. So 9x is equal to, how can I simplify log base 7 of 15? Log of 15 over log of 7. Now we're going to put this into the calculator. So we should get 1.392. Now am I done? What's the last step? Divide by 9. Since it's 9x, since 9 is being multiplied to the x, I got to divide both sides by 9 to get that x all by itself. So we just divide the 1.392. You could just leave it in your calculator and click divided by 9. You should get 0.155. All right, this one's a little bit different. What do you think I have to do first here? Add 7. We want to get the number with the exponent all by itself. So I'm going to add 7 on both sides. So 4e to the power of negative 0.3x is equal to 20. What do I have to do next? Again, we want the number with the exponent all by itself. I have to divide by 4 to move that 4 to the other side now. Because 4 is not the number with the exponent. 4 is being multiplied to the e. So I divide by 4. We get e to the power of negative 0.3x is equal to 5. Now that I got the number with the exponent all by itself, what could I do? Log with what base? What is log base e? ln. So we could just take the ln of both sides, or you could do log base e of both sides. Same thing, log base e is ln. So I'm just going to take the ln of both sides because it'll be one less button to click in my calculator. But we can only do that when the base is e, because ln is log base e. So I'm going to take the ln of both sides. So the ln of e cancels. What am I left with on the left side? Negative 0.3x is equal to the ln of 5. What do you think I would have to do next to solve? Find the ln of 5. So ln of 5 is 1.609. What would I do next? Divide by what? Negative 0.3. So we divide both sides by negative 0.3. So x is equal to negative 5.3647, which would round up to 5. So we need the number with the exponent. All by itself. All right, next we're going to be solving log equations. So we're doing pretty much the same thing, but if we have an equation with log, so if we're taking the log with an x in it, we're going to use exponents to help us solve now. But then also we have the case where if we have log base 2 of x is equal to log base 2 of 7, when you have the same base, the log base 2's will cancel, and you could just say x is equal to 7. So you can just say what you're taking the log of is equal to each other. But this only works when you have one log on each side, if it's just the log is equal to a log. All right, so looking at example A, the ln of 4x minus 7 is equal to the ln of x plus 5. So same thing that we had if a log is equal to log. If we have an ln is equal to an ln, we could just cancel out the ln's and say 4x minus 7 is equal to x plus 5. So we just set the rest of it equal to each other. Does everybody see what I did there? Okay. From here, we just solve for x. So what would I need to do to solve for x? Subtract the x. So move the x's to the left. So that means our constants are going to go to the right. So I'm going to add 7, move that to the other side. So 3x is equal to 12. Divide both sides by 3. So what does x equal? 4. Awesome. Let's look at B. So here, do I have the log is equal to a log? No. So we can't just cancel them out like we did in the last one. So you gotta work a little bit harder this time, but it's not too bad. So if my base is 2, I'm going to make my big base on both sides be 2. So I'm going to change this to be 2 to the power of log base 2 of 5x minus 17. And it's equal to 2 to the power of 3. So whatever the base is, we make the big base that number. And we made all of it an exponent. So we make the big base the same as the little base. Since my little base was 2, I had to make the big base 2 on both sides. Because on the left side, how would I simplify 2 to the power of log base 2 of 5x minus 17? Anything cancel there? What? 2 to the power of log base 2. So I'm just left with 5x minus 17. On the right side, what's 2 to the third power? 8. Everybody good so far? What would I do next? Add 17. So 5x is equal to 25. And then what? Divide by 5. So what does x equal? 5. Awesome. Let's look at the next one. So here, we need to just have one base on one side. So we want to condense the left side. Condense to only one log. So on the left side, how do you think I could condense to just have one log? Awesome. Since we are adding, we're going to multiply them together. So I have the log, and I multiply the two things that I'm taking the log of together. So the log of 2x times x minus 5. I'm multiplying these together. Now I can multiply it. I don't have to leave it as 2x times x minus 5. How would I multiply these together? Two x squared minus 10x. So we have to distribute the 2x to both things. Okay, now I want to get rid of that log from my equation. So how could I get rid of the log? What's my little base? The little base here. 10. Remember, if there's no base written, it's implied that it's a 10. So to get rid of the log, I have to make my big base whatever my little base is. So I'm going to make both sides 10 to the power of whatever's already there. So I have 10 to the power of log base 10 of 2x squared minus 10x is equal to 10 squared. So on the left side, what happens? 10 to the power of log base 10 cancels. So I'm just left with 2x squared minus 10x. On the right side, what's 10 squared? 100. How would I solve when I have an x squared and an x in the same equation? We have to factor. What do I need in order to factor? What would I have to do first here? Perfect. I need it to be equal to 0, so I'm going to subtract the 100 on both sides. So 2x squared minus 10x minus 100 is equal to 0. We could do first times the last, but do I have a GCF? 2. So let's just divide everything by 2. Get rid of that 2 so we don't have to worry about first times last. We're dividing everything by 2, even the 0. That way it just goes away. So x squared minus 5x minus 50 is equal to 0. So the 2 just goes away because I just divided it out of my equation. Now let's factor. Do I have two factors of negative 50 that add to negative 5? Negative 10 and 5. Awesome. So x minus 10 times x plus 5 is equal to 0. Set them both equal to 0, so x minus 10 is equal to 0, and x plus 5 is equal to 0. So what does x equal? 10 and negative 5. We're almost done. If you get two answers, you have to check your work. You can't take the log of a negative number. So we want to take both of these and plug it back into the logs that we have and see if we get a negative that we're taking the log of. You don't have to evaluate it all the way, but if you have log of -10, it's not going to work. So we're going to plug in, let's try the 10 first here. Now it's not always going to be the one that's already negative, but sometimes that's usually the case. So let's check. I have the log of 2 times 10, because we're plugging in 10 first. We're checking our first one. So log of 20, that works because it's not negative. And then I have the log of 10 minus 5, which would be 5. So that's also positive, so that works. So 10 works as our answer. X is equal to 10. That's good. Let's check the other one too. We're going to check 5, -5. So the log of 2 times -5 would be, if I plug it into the x there, what's 2 times -5? -10. Can I take the log of a negative? No, so it does not work, so -5 is not a solution. So the only answer is x is equal to 10. Sometimes both answers will work. So you just always have to check both. Sometimes the negative answer will work. It's not always going to be just the positive one that works, but you cannot take the log of a negative. Cannot take the log of a negative number. All right, we have a few more examples on the last page, so we'll do a couple more together. Let's look at number 5. What would I do first for number 5? Cancel the ln's. If we have an ln is equal to an ln or a log is equal to a log, cancel. And then we just set the rest of it equal to each other. So 7x minus 4 is equal to 2x plus 11. Then from here, we just solve for x. What would I need to do first? Subtract 2x, and we can add 4. So 5x is equal to 15. Yep. Then what do? Divide by 5, so x is equal to 3. Awesome. What do I have to do to solve for 6? I got to get rid of the log. How?
So big base is 2.
Make the big base 2. Since my little base is 2, I make the big base 2. So on the left side, 2 to the power of log base 2 cancels, and I'm left with x minus 6. On the right side, we have 2 to the power of 5. What's 2 to the power of 5? $32. What would I do next? Add 6. So x is equal to 38. So we're going to do the one right below it. So what do I have to do first for 8? I have to condense them, and since I'm adding, I'll multiply them together. So I combine them to log base 4. And it'll be x plus 12 times x. So I just multiplied the two things that I was taking the log of together. So we had to condense to one log first. Just because I'm taking the log of everything, you don't have to. It's just like part of the work. That way we don't think we're only taking the log of one of them. All right, let's multiply these together on the inside. So I have to distribute. So I have log base 4 of what? X squared plus 12x. All right, now how do I get rid of that log? What did I do in the last one? I make the big base 4. So 4 to the power of log base 4 will cancel, and I'm left with x squared plus 12x is equal to 4 to the power of 3. What is 4 to the power of 3? 64. What do I have to do next? Factor. So what do I need in order to factor? It's got to be equal to 0, so I got to subtract the 64 to the other side. So x squared plus 12x minus 64 is equal to 0. Do I have two factors of 64 that add to 12? (16) and -4. Awesome. So x plus 16 times x minus 4 is equal to 0. What do I do next? Perfect. Set them both equal to 0. So x is equal to -16 and x is equal to 4. Now we have to check. So if I plug in -16 into my x here, I get -16 plus 12. So that would be -4. Can I take the log of -4? We plugged in -16 into our x. We check because we can't take the log of a negative. So we got -4. Can I take the log of -4? No. So does -16 work? No. We can check 4 by plugging it in. So let's be super sure. So we have 4 plus 12 would be positive 16. Can I take the log of positive 16? Yeah. And then if we plug it into the other one too, can I take the log of 4? Yes. So 4 works. So our only answer is x is equal to 4.